Welcome to another lecture video on junction field effect transistor. In this particular video, we will discuss the construction and the working principles of JFET. Before we talk about the structure of JFET, let us look into one particular question which has significant importance. In case of BJTs, we found out that the NPN transistor is widely used. Why is it so? It is because of the fact that in case of NPN transistor, the majority charge carrier is electrons. In case of PNP transistor, the majority charge carriers are holes. We know the holes have more effective mass compared to the electrons. Therefore, electrons have high mobility compared to the holes. This is the reason why NPN transistors or NPN bipolar junction transistors are widely used. Similarly, JFETs are also of two types: N-channel JFET and P-channel JFET. The N-channel JFETs are preferred because here the majority carriers are also electrons. We now focus here on the operation of N-channel junction field effect transistor. Before we look into the working principles of JFET, let us talk about some properties of JFETs. In addition to the channel, JFETs also have two ohmic contacts. One is source, another one is drain. JFET will conduct current equally well in either direction, and the source and drain leads are usually interchangeable. The magnitude of the current is controlled by a voltage applied to a gate, which is reverse biased. The fundamental difference between JFET and BJT devices: when JFET junction is reverse biased, the gate current is practically zero, whereas the base current of BJT is always some value greater than zero. JFET is a high input resistance device, while BJT is comparatively low. If the channel is doped with donor impurity, N-type material is formed, and the channel current will consist of electrons. On the other hand, if the channel is doped with acceptor impurity, P-type material will be formed, and the channel current will consist of holes. N-channel devices have greater conductivity than P-channel types, since, as we have already discussed, the electrons have higher mobility than holes. Thus, N-channel JFETs are approximately twice as efficient conductor compared to their P-channel counterparts. Let us now look into the schematic of JFET and understand the structure of a JFET. A JFET is a three-terminal device. All the terminals have ohmic contacts. This terminal is named as drain, this is named as source, as we have already discussed, the source terminal and the drain terminal can be interchanged. These two contacts are basically connected, and this terminal is known as gate terminal. The main material in this particular structure is this N-type semiconductor. Two P-type materials are embedded in these two sides on this N-type material. This N-type material is also known as a channel. As we can see here, there are two PN junctions. One is this particular PN junction, the other PN junction is over here. Since there are two PN junctions, there will be two depletion regions. This is one depletion region, this is the other depletion region. The depletion region, as we know, is void of any charged carriers. The width of the depletion region is controlled by the voltage applied between gate terminal and the source terminal. Now, if the width of the depletion region is increased gradually, as we can see, the gap between these two P-type materials will gradually decrease. That means the channel formed between these two P-type materials will gradually reduce. As a result, when we apply a potential difference between the drain terminal and the source terminal, there will be flow of charged carriers. In this case, the majority charge carrier is electrons. If we apply positive potential to the drain terminal and negative potential to the source terminal, the electrons will flow towards the drain terminal. Now, if the width of the depletion region gradually increases, the width of the channel will reduce and the flow of charge carriers will be obstructed somewhat. This is briefly the structure and the working principles of JFET. In the upcoming lecture video, we will look into the working principles of JFET in more detail. Thank you for listening to this lecture video.